And we are taking a look at question 23 here in section 4 of SAT Practice Test 4. So here we see these two tables, and it says in the question, the tables below give the distribution of high temperatures in degrees Fahrenheit for city A and city B over the same 21 days in March. And so we see here city A, city B. And the question asks, which of the following is true about the data shown for these 21 days? And we see that the answer choices are describing the standard deviation. So SAT is not going to require you to do a numerical calculation for standard deviation, but they do want you to qualitatively and conceptually understand what standard deviation means. And standard deviation, we'll put it over here just as a good takeaway, is that your standard deviation is going to tell you, in layman's terms, think of it as spread. It's how spread out the data is. So as long as we understand that concept of what standard deviation represents, then conceptually that should be enough for us to answer standard deviation questions correctly. Now let's talk about how we can recognize how spread out the data is when we look at a table like this. Again, we're not going to have to calculate it numerically, but if we look at the frequency of each of these results, so here, temperature of 80 in city A has frequency of 3. So that means there were 3 days that had a temperature of 80. There were 14 days that had a temperature of 79. There were 2 days that had a temperature of 78, and 1 day with 77, 1 day with 76. So what we want to look for when evaluating standard deviation is we want to look to see frequency-wise if we have any particular result that shows up very commonly. And here we see that with the temperature of 79, it has a frequency of 14, which means that your results are clustered around this particular value. So this is a significant cluster, and when the data is scrunched together like that, that's going to indicate, whenever you see a big cluster like that, that's going to indicate a lower standard deviation. So you'd have a smaller value for standard deviation here. And when you look at city B, so we have 6 results of 80 degrees, 3 days where it was 79, 2 where it was 78, 4 where it was 77, and 6 where it was 76. So you see how overall this is a little bit more balanced? So when you see something like that, if it's a little bit more balanced, that means that it's going to have a larger standard deviation because the results are spread out. Think of it as they're being spread more evenly across. Kind of like if you were just, spreading some butter on a piece of toast, right? So a perfectly even spread is going to indicate a large standard deviation. And if you go to spread out that data and you see that you have a big cluster, big clump in one spot, that's going to indicate a smaller standard deviation or a smaller amount of variability in that data. So for our answer choices, standard deviation of temperatures in city A is larger, standard deviation of temperatures in city B is larger. Well, when comparing those two, we can see that B is more spread out. It's going to have the larger standard deviation. That's going to be answer choice B here on question number 23. All right, let's take a look at 24. So on this next page, for 24, it says, in the circle above, segment AB is a diameter. If the length of arc ADB, which means we're going this way, is 8 pi, what is the length of the radius? Well, they want to know radius for this, and since they give us this arc as 8 pi, we want to figure out if there's a formula that we know that has something to do with arcs or outsides of circles and the radius. And this entire arc of the circle as a whole, which is called our circumference has a formula. We should know it, but if you don't, it is given in our little cheat sheet at the beginning of the math section. If you're really pushing yourself for a 600 or 650 plus, I do recommend memorizing every single one of those equations and pieces of information given in that cheat sheet, but your circumference is 2 pi r. It's worth memorizing. And here, for our circumference, remember, our circumference is not the 8 pi. That's just half of our circumference. But if we look at the other arc around the other half of the circle, that's also 8 pi. Your circumference is going to be 16 pi. We have to combine those values, and that would equal 2 pi r. Now to solve for r, our pi's cancel, and we can divide 16 by 2, giving us 8 for our radius of this circle here.